We just found out an AI scanning tool, after a mere hour, discovered a logic flaw in the Linux kernel that's been there since 2017. Not only found it, but generated a full exploit and even a dedicated website for CVE 2026-31431, impacting virtually every Linux machine updated since then. Think about that. A system designed as the digital bedrock for millions of devices, orchestrating thousands of tasks, with its intricate ballet of hardware and software, was hiding a critical vulnerability humans missed for years. This isn't some minor bug. This is about the very foundation of how Linux operates. From the moment an operating system like GM Neo, first taking shape in 1956, wakes up components via firmware like UEFI, hands control to a bootloader such as Grub, and loads the kernel into RAM, granting the CPU full hardware privileges in Ring 0, it's a marvel of engineering. Virtual memory is established with page tables and MMUs, translating fake virtual addresses into real physical ones. Managing memory in isolated 4 kilobytes pages. Device drivers load into kernel mode, registering specialized code to translate requests into hardware instructions for GPUs or Wi-Fi cards, signaling the CPU via interrupts. Then PID1, typically System D, kicks off, setting up the first user space environment. Every subsequent operation demands a system call to transition from user space ring 3 to kernel space ring 0. This entire, robust architecture, built on essential calls like fork and exec, and managed by schedulers like earliest eligible virtual deadline first, with threads handling concurrent tasks, it all seemed unassailable. Yet, this deeply complex foundation was critically exposed by a logic flaw that targets the kernel directly. This vulnerability, which requires local user access or an existing system foothold, allows an unprivileged local user to inject 4 uncontrolled bytes into the page cache of any readable file. The mechanism behind it is surprisingly specific. It leverages the ONC-ESN feature, accessible via the AF_AGL interface, to misdirect scratch data through the AFG splice function. The result? Root access to read-only files. Like the crucial su command, it's a precision strike against the very heart of the system. And this isn't theoretical. CrowdStrike and CISA have already confirmed active exploitation in the wild, adding it to their known exploited vulnerabilities list. A simple script, similar to ones already circulating, can easily take control of machines using common tools like Metasploit. The AI's rapid discovery fundamentally shifts the landscape of vulnerability research. This universal Linux privilege escalation, theoretically valued anywhere from $10,000 to $7 million on the gray market, was found and a proof of concept released for free by Theory, all within approximately 1 hour by an AI agent. This flaw, traceable to 2015 and 2017 kernel commits, touches every major Linux distribution, Debian, Arch, Red Hat, underscoring an immediate, critical need for updates across the board. The implication is stark. This AI-driven insight revealed a flaw that, in essence, could compromise every Linux machine on planet Earth. It makes you wonder, if an AI can find something so fundamental, so quickly, what does that say about the security challenges ahead, and the urgent demand for high-quality code from the AI coding agents we're building?